Hello everyone. Welcome to our video for today. As what I promised you guys in our last video, that we will make another design, logic design, that will reverse or invert our output. Before we have before in our previous design, we have our output 0 0 1 0 1 1 1 0. So now by this time we reverse it or inverse it to 1 1 0 1 0 0 0 1. So we'll see guys if we can make a circuit out of that output and combination of inputs. So guys, we make a function out of this output. We'll erase this one. Out of this output 11010001. This is our Boolean function from this output. X again, we have to consider only one output. This one, and this one. That's only our concern. And the 0, don't mind zero output. Now, our Boolean function out of these combinations with one output, so x0, y0, z0, so one output, so we have x bar, y bar, z bar. Then the next inputs x0, y0, z1, output 1. So we have x bar, y bar, z. Then plus the next output with one output x0, y1, z1, output is 1, and the function is x bar, y, z. And the last output, all inputs are 1, 1, 1, 1, x 1, y1, z1, output 1, and the function is x, y, z. Now simplifying that function or Boolean function using like ordinary mathematics, finding the same variables. So we pair these terms. So the common here is x bar, y bar, x bar, y bar. So x bar, y bar, then the remaining is z bar, z, then z bar plus z. And if you remember, I said in Boolean laws, z bar or any variables, z bar plus z or z plus z bar or whatever variables, that is equal to 1. Okay? In the other one, and the other two terms here, we pair the other two terms. What are the common variables? Y z here. So yz, parenthesis, x bar plus x, close parenthesis, then that is equals to 1 as well. Same with this, z bar plus z equals to 1, x bar plus z equals to 1. So the remaining function is yz, and the other side is x bar, y bar. And finally, our function of f, simplified function, is equal to x bar, y bar plus yz. In keymap method here, xy on the top, z at the bottom. So combination of xy is 0, 0, 0, 1, 1, 1, 1, 0. Again, if you remember again last time, I said like that one, and the other two quadrants is that one. So meaning like in two variables truth table, because we're dealing with xy on the top of this map. So let's say this is xy and this is xy. This 0, 0, 1. One, then 0, 0, 1, 1, and this is 0, 0, 0, 1. Now we are concerned with this one. So 0, 0, 0, xy, 0, 0, 0, 0, then 0, 1, zero, 1, 0, 1, sorry, so that's 1. This is 0, sorry, that's 1. Okay. This is 0, 0, 0, 0, then 0, 1, 0, 1, and here is 1, 0, 1, 0, this 1, 0, and last is 1, 1, 1, 1 here. Okay, so that's the how you arrange these inputs on the top of your key map. So the other side is at the bottom, z, 0, 1, only two combinations of inputs. So now we look for the output here at our truth table, 1, 1, 1, 1. So where's the 1 in our truth table here? Because we have output of 1 in x is 0, y is 0, z is 0. Output is 1, so 1 is here. Here, 1. Then for the next combination, 0, 0, 1, 1 output. 0, 0, 1, 0, 0, 1 here. X is 0, y is 0, z is 1. Then the third one here, what are the inputs? X0, y1, z1. So 0, 1, 1. So 0, 1, 1. So this one, you have an output on this quadrant. Then finally, x is 1, y is 1, z is 1, 1 output. So x is 1, y is 1, z is 1, and they intersect on this quadrant, so this is 1 here. So in key mapping method, the technique is you have to pair the two output or two ones that they are adjacent with each other. So 1, 1, and another one is 1, 1. So you can pair also this one. So this one, this pair. So if you look at xy is 0, 0, and z is 0, 1. So z, output of z here is changing from 0 to 1 or 1 to 0. So that is cancelled or equal to 1. Same as here, same as this one. Z bar plus z, x bar plus z equals to 1. So same this one. Z is 1, z is 0, z is 1 on this two quadrants here. So that is equal to 1. So the remaining here is xy. xy, but but since it is 0, so that's why x bar, y bar. So because that's 0. Now the next pair here, xy is 0, 1, and on this quadrant here is xy 1, 1. So what is the variable that changing here? X 0, 0, 0, 1 and 1, 1. So the variable that changing here is the x 0. The x here is 0, and in this quadrant here x is 1. So 0, 1 equals, that is equal to 1. So the remaining here is y 1, 1 plus z here. So the output here is yz. So yz, y 1, 1, y is 1, 1 and z is 1. So yz. Alright, so finally, therefore function of f using the KeyMap method is x bar, y bar plus yz, same as here. Same with this simplification here. Okay, so they are equal. X bar, y bar plus yz. Same also here, x bar, y bar plus z bar. How to prove that this is correct? This output is correct based on the truth table here. Let's say we'll try this first. The 0, 0, 0 equals 1. So if x is 0, y is 0, then plus y is 0, z is 0, all zeros. So since this is bar, this will become 1, this will become 1, and this one is as is on the other side, 0. So plus this 1, 1, 1 times 1 is 1, plus 0 here, that is equal to 1. So that's why this is correct. And this function is correct. This one. We'll say another one here. This one. We'll prove this one, this output here. 0, 1, 1. Okay? Oh, we'll here. 0, 1, 1. 0, 0, 1, 1 is 1. So here in our KeyMap, x is 0, x is 0, y is 1, plus y is 1, and z is 1. And since x, this is x bar, so this is 1. And since y is equals to 1 bar, so this is 0. And since all this is not, there's no bar here, so 1 times 1 is 1. So answer is here is 1. And here is other side is 0. But this is plus sign. Okay, so this is 0 plus 1. That is equal to 1. So correct. Right? Our output here is 1. So this function that we got in our KeyMap method is also correct. We prove also here in our KeyMap simplified output is correct. Same also here. Alright? Now, let's proceed to our function, implementing function using basic logic gates. So x, y, z, so that is our implementation. So this is, I forgot to put the label. This is x bar, and this is y bar. So the output here is x bar, y bar, because this is AND gate. This drawing is AND gate. AND meaning multiply. And this inverter gate. There's another AND gate here. So that is X bar, Y bar here. X by Y bar. And the next is YZ. So Y, we tap on Y connection, Y. So another AND gate. Then Z. Okay. Another input of this gate. Then the output is YZ. Okay. Then, since this is plus, and that is OR gate. Okay. So this is the drawing of our OR gate. So X bar, Y bar plus YZ. So finally the output here, F, is equal to X bar, Y bar plus YZ. So this is the final output. So this is our logic diagram. So very simple. So how many gates? 1, 2, 3, 4, 5 gates. 2 inverters, 2 AND gates, and 1 OR gate. Now, let's proceed to our actual IC drawing. So this is 7404 inverter gate. This is 7408 AND gate. And this is 7432 OR gate. So this one, in one single chip of this 7404, it has 6 gates inside. No? 6 gates inside. So 6 inverter inside. And for the AND gate, since this is only 2 inputs, so we have also 4 gates inside. So we call this as quad AND gate. And this is hex OR gate, hex, since 6 gates inside. And for the OR gate also, this is a quad OR gate, 4 gates inside. Okay, so this is our connection. So same as here, but by this time this is the actual IC drawing. So but same with this, no? Same with that one. So but we have supply 5 volts, we have ground, right? It's the actual pinnings of our IC. If you can, if you want to, I will show you the actual here. Like for example, the actual pinnings in the internet. They say 7404 pin out. Okay. So yeah, that one. Okay. But they don't put bubble here. It's like a buffer. No, that's wrong. This one is correct, right? That's 7404. Same also this one. That's 7404. Okay. So again, this one is, for me, this is wrong because they don't put a bubble at the end of like an arrow or a triangle, a lying triangle. So that's wrong. We can misinterpret that as buffer because there is an IC that using this symbol without bubble, we call that as buffer. So buffer like an amplifier, you know, the amplify current or signal when you connect too much connection for a certain IC. So you have to have this IC as amplifier, or we call that buffer. So this is wrong presentation for the 7408. And for the 7408 AND gate, so we have your 7408 pin out. Yeah, so that one. Okay, so that one is the 7408. So that's 14 pins IC. 14 is BCC or positive supply, and 7 is the ground. So those are the 7408, 7408. Okay, 7408. Alright, for the 7432 IC, pin out. Yeah, that one, 7432. 7432 OR gate. OR gate circuit diagram. Okay, that's OR gate. Okay, OR gate. 7432 OR gate. Okay, so we back here for the data sheet of this IC. No? What are the parameters? Like 7404, 7432, let's say 7432, what do you call that? Data sheet. Okay, we'll see this one. So what are the parameters you have to consider in using this IC? Yeah, this one. This not here. We'll try this one. Yeah, this one. These are the. Yeah, this one. This is the correct data sheet. You can see here the voltage, the supply voltage. Okay. Yeah, the BCC supply voltage 4.75 to minimum is 4.75, maximum is normal is 5 volts, maximum is 525. Okay, the high level input, it must be at least minimum of 2, and yeah, wala na siyang iba, minimum of 2 for considered as high input. And for the low level input voltage, maximum is 0.8 volts for the considered as low. Okay, so temperature, everything here. So those are the parameters you have to consider in dealing with this IC, 7432, 7408. Actually, they are rugged ICs, no? Unlike the other ICs, like we'll discuss later on about CMOS, no? The complementary metal oxide, semiconductor ICs that are sensitive in static electricity, no? You have to be grounded in handling that kind of IC. But this one is a TTL. This for me, this is a rugged one. Okay. So we have here the actual. No, we have the actual. This one. So we have here the actual. Okay. And as you can see here, I included in the drawing the, because we connect this to 220 volts. Okay, we put a load of 220 volts EC, the bulb here, and we have also the LED display, 5 volts for the 5 volts output for our final F. Yan, this is the small display, the LED, and this is our high voltage display 120 volts bulb. Okay, so when this LED goes on, this will also goes on. Okay? So, and this one, by the way, this bulb is connected via relay. So this is our interface between 5-volt circuit to 120 volts supply. So one line of the 120 volts AC will pass through relay, normally open. So when this relay switch on, this contact will connect to this normally open contact. Then it will turn on the bulb. Then meaning if one will goes this line, one meaning approximately 5 volts, it will trigger the relay. This relay is a 5 volts relay. Then this will change the contact here, normally close. Then the 120 volts can flow from through relay going to the bulb, then back to the source. Okay, so that's the concept. So this one, so we have here the relay, the array of relays here, but we're using one relay here. Where's that? But I think this one. Okay, so moment of truth. We'll try this combination of inputs, using our manual input here, toggle switches representing X, Y, Z, then our output. Okay, so our display. So let's start. If input is 0, 0, it must be 1. So expect that our bulb will light or will turn on, and also this small LED. So 0, 0 meaning 0, 0, 0. Okay, 0, 0, 0. Look at that. Our output is on. Okay, that's 1. The next combination is 0, 0, 1, still 1 output. So X is 0, X is 0, Y is 0, Z is 1. Okay, no changes in the output. Same, on. Okay, 1. And for the third one, we put a decimal number here, so that will not get lost. 0, 1, 2, 3, 4, 5, 6, and 7. Okay. For number 2, combinations of input, so it must be 0 output. So yan, we'll try 0, 0, 1, 0. So X is 0, Y is 1, Z is 0. So look at that, our bulb turned off. Okay, goes off. So this is 0, 1, 0. 0, 1, 0, the number 2. 0, 1, 0, 0, 0 output. And the third, number 3 is 0, 1, 1. X is 0, Y is 1, Z is 1. So X is 0, 0, Y is 1, and Z is 1. Okay, so look at that, it goes on. So 0, 1, 1. Number 3, 0, 1, 1, output 1. Number 4, 1, 0, 0, it must be 0 output. So Y is 1, X is 1, Y 0, Z 0. X is 1, Y is 0, Z is 0. So, output is off. Output is 0. And the fifth 101, output is 0. X is 1, Y is 0. No. X is 1, Y is 0, and Z is 1. Okay. So, no output. 0 output. Number 5, 101. 1, 0, 1. Okay? And number 6, still 0 output. 110. X is 1, Y is 1, Z is 0. So, X is 1, Y is 1, Z is 0. Okay? So, output is 0. Output 0 here. Output 0. Okay? That's number 6, 110. 110. Finally, 111, output 1. All ones. So, X is 1, naka 1 na yan. It's already in 1 position. Y is already in 1 position. And Z is in 0, so we have to switch to 1. Okay? So, 1, 1, 1. 1, 1, 1. Output is 1. Output is 1. Okay? So, bingo. So, we followed our output, meaning our simplification is correct, everything, our diagram is correct because we follow that one in, breadboarding this one. So, we just follow that one here. So, it's correct. Okay? So, again, I just want to emphasize that the good thing in digital electronics or digital design is you can create your own circuit, your own desired circuit output. So that's the good thing in digital electronics. Everything you have in your mind, you can implement that one using logic gates. All right? So that's all for now, guys. Just continue watching our video so that you can have a good idea later on how digital electronics works, right? So that's all for now, guys. Bye.